Good day, everyone. My name is Sulaiman Ahmed Abiodun. I'm a doctoral student in the Department of Archaeology and Anthropology, University of Ibadan, Nigeria. My paper for SAFA conference is entitled The Technology and Production of Iron Metallurgy in Ile-Ife, Nigeria, between the period 1100 to 1900 AD. This research work is a collaborative one, and as such, it involves many other scholars. My PhD research forms an integral part of this work, which of course I'm presenting part of the research done so far in 4 different sites in Ile-Ife. Slide 2. It shows the map of Ife, the images, the close of Oromiyan, Idena, and then the MSA all in iron. This shows the cultural importance, the symbolic nature of iron in ancient Ile-Ife. Of course, it emphasizes the fact that, particularly on Oromiyan status, we have inscription of iron on them, which of course symbolizes the fact that Oromiyan, who was once the king of Ile-Ife, was a warrior. And at the same time, up to today, whenever the king of Ile-Ife, which of course referred to as Oni, is going to any engagement, we have people around him, the entourage, ringing bells before he make any official procession. Slide 4. It shows the background of the site, that is the landscape. There are 4 sites that were investigated. 3 of them are the center of Ile-Ife, and these are Ife Grand Resorts, IGR on the slide. We have Bafemi Awolowo University Commercial Farm, which is OAU on this side. Then we have Iyekere Iwarhi on the slide. And the 4th one is Bakun BAK. Of all these 4 sites, 3 of them of the sites are located not too far from one another. As a matter of fact, they are not more than 10 kilometers, except Bakun, which is on the outskirts of Ile-Ife. Geologically, they are similar. They have gneisses, they have schist. These are metamorphic rocks. In terms of ore, they have lateritic ironstones. They also have iron-rich ilmenites and magnetites. And then we also have black sand, which is very, very rich in ilmenites. Slide 5 shows the background excavation pictures. The slags to yays are from the site. Now, when you look at some of the samples that we recovered so far, we have abundant slags, we have tuyeres, then we also have furnace walls. But one thing is very peculiar about the 4th site, which is Bakun. We were able to recover furnace base, which were not in the 3 other sites that are at the center of Ile-Ife. I mean, OAU, IGR, and then Iyekere. But for Bakun, which is on the outskirts of Ife, we recovered a remnant of furnace base. The slags were recovered in thousands for all the sites. The least recovered is 1,000 kilograms from Iyekere. Others are above 1,000 kilograms. We also have abundant tuyeres, which of course signifies smelting in the area. Then chronologically, the sites span 777 centuries, with Ife Grand Resort being the oldest, dated between 13th and 15th century. That is Ife Grand Resort. Whereas Bafemi Awolowo University sites and Iyekere, they span between 17th and 20th century. However, we were able to understand the fact that in terms of chronology, because Bakun, which is of course is the most recently excavated site, has not been dated. Therefore, we cannot place it chronologically now. But of course, we can, based on the documented reports, that Bakun was founded 11th century. How true is this? Not until we date materials from Bakun, we were able to recover charcoal sample from the base of the furnace. Then we can then place Ife in terms of chronology vis-a-vis other sites that were investigated. Of course, we expect dates from Bakun to be earlier than that of OAU, IGR, and then Ife Grand Resort, because it is located on the outskirts of Ife. People might have settled on the outskirts before they now move into the interior. Slide 6. Material and method. From the pilot study, 9 iron slags were selected, 2 from IGR and YIA, and 5 from OAU for optical microscopy. Element analysis were done by SEMEDS. The samples from OAU were prepared at the laboratory facility of the McDonald Institute Archaeological Research Center, University of Cambridge, that is in UK. All samples were analyzed at the Archaeometry Lab of the Science and Technology in Archaeological and Cultural Research Center, that is STAC, of the Cyprus Institute in Nicosia. Slide 7. It shows the result of the optical microscopy. That is, what do we see in the data? Microscopically, the slags appear homogeneous. Phyritic iron silicate dominate the primary phase in a dark grayish glassy matrix. The phyllite is elongated in a skeletal pattern grown perpendicular to the original phase. This elongated formation of phyllite suggests rapid cooling. And that shows the technology they were using there, the kind of temperature. That is, it was rapid. Slags were formed, iron booms were formed under a very rapid cooling system. This is a phase of magnetized skin observed, suggesting tap slag. Of course, this also suggests tap slag. All the samples show free oxides with metallic ion spray scatter in the slag matrix. Like I said, shows tap slag very lean with free iron oxides. And now proceed to give the composition analysis, which of course forms slide 8. It shows the composition table of titanium oxide versus iron oxide graph. All are reasonably rich in titanium. About 80 to 90% of all the samples were rich in titanium, from OAU to IGR to Yekere. All the sites, they were rich in titanium, except Bakun, which is yet to be analyzed. It has been observed that earlier in the work of Ige and Reren, with many titanium-rich spinel crystallizing, but there are differences. The slag from IGR, that is, if a grand result between 13th to 15th century, they are richer in iron oxide and much lower in titanium than others. Potentially, it may be different from a different ore. On the other hand, OAU, which of course is between 18th and 20th century, the slags were richer in titanium and have much less of iron oxide. Graphs. The next slide, of course, graph titanium oxide versus iron oxide shows this. Now, the next slide, which is of course is slide 9. This graph shows the relationship between magnesium oxide versus manganese oxides and magnesium oxide versus phosphorus oxide. Some of the observations show clear clustering of slag according to their minor oxides, such as magnesium oxide versus manganese oxides or magnesium oxide versus phosphorus oxide. This is puzzling and is still under investigation, but it shows that there is a difference between the different slags heaps. Slide 10 shows the ternary diagram. Of course, it shows that all the samples, they are well behaved. They form into the eustatic trough and in low melting regions. The entire system shows that the temperature of the entire system is lower than individual constituents of the system. And as I conclude, what would this mean for understanding the evolution and revolution of iron metallurgy in Ilefe through time? Slide 11. Discussion and conclusion. Maybe two different ore, more rich in aluminium, electrosilica, and lower in titanium oxide than the other. The more recent ones are clearly based on titanium-rich black sand, which raises the question of how practically it is possible to smelt ore if you have sand falling through the stacks of charcoal lumps in the furnace. Also, it may indicate a change in ore procurement, from shallow mining in bauxitic ironstone ore in agricultural land to washing black sand from the riverbeds. If this is the case, how to prevent the black sand from falling through the furnace quickly? Maybe by mixing with the local clay, making pellets. This could explain the aluminium to silica ratio, bringing the silica into best melting position in the ternary diagram and helping slag formation. We will have to analyze the local domestic pottery as a pottery in order to understand this hypothesis, why we have more of aluminium to silica in the whole analysis. This clearly shows the fact that people actually in the past, they were using as between the period of 18th century upward, they changed in terms of ore procurement to using black sand in iron smelting. They were more into using black sand in iron smelting between the period of 18th century upward, unlike 13th to 15th century when they were using more of ore, which of course that is the limonites. But between that 18th to 15th century, they were using more of black sand, and black sand, it has more of ilmenite in it. Ilmenite has what we call titanite in it, titanium. And that is why we have more of titanium oxide in the analysis. And it shows that because people actually change the source of raw material procurement as time progresses from 13th to 15th century, they were using more of ore of limonite, whereas from 18th to 20th century, they changed to using black sand for iron smelting. Now, the question is, why did they change? Was it because they have access to more of black sand from the stream during the period 18th to 20th century? Can this be climatically induced? Was it because they accidentally mixed the two together during the course of time? These are one of the questions which, of course, my research in progress intend to answer. Why do we have more of titanium oxide during the period of 18th to 20th century? Of course, we know that more of titanium, but why did they choose that during that period? There was a change in material procurement between 18th to 20th century. Then we begin to look at possibilities. Bauxite ironstone during the classical era versus black sand between 18th century upward. Of course, I said there was change in raw procurement. Then innovation through time. It shouldn't be possible for them to actually smelt black sand without adding clay into it. It's an hypothesis. Now, if they actually added clay into the whole thing into the system before smelting, then what can we say about the quantity of clay added? Then how sure are we that they actually added clay to the black sand in the furnace so as to extract iron? We must test hypothesis by understanding the nature, the composition of the non-technical ceramics and comparing it with the clay composition in order to actually understand why they actually added clay to the black sand in order to smelt iron. Thank you for listening, and I would like to acknowledge the following. 1. The Stark Institute in Nicosia, Cyprus. McDonald Institute in the United Kingdom for the analysis. I also want to thank Professor Tilo Reren and Meghna Desai of Cyprus Institute as well for carrying out the analysis, technical aspect of the work. Actually, they did the analysis of the slags. Then, I also want to appreciate Dr. Tony Abala of the British Museum. He was me throughout my excavation period in both at Yekere and Bakun. And then lastly, I also want to appreciate Professor Aki Ogudingan, who actually initiated the Agbaje Williams 2025 grants, which I won. Thank you so much.